An introduction to NumPy. What is NumPy? NumPy stands for Numerical Python. It is an open-source Python library that is extensively used in science, engineering, or data science. The NumPy API is used extensively in other important Python libraries such as Pandas, SuMyPyLab, Matplotlib, scikit-learn, etc. NumPy provides ND-array, a homogeneous n-dimensional array object, with methods to operate on it efficiently. If the NumPy module is not available on your system, you may install it using the pip command, that is, pip install NumPy. For working with the NumPy modules, you need to import it using the import command. In general practice, the module is renamed as NP during import. You are also advised to stick to it. Before we discuss anything more, let's do some practical tasks and get some idea how it works. So, let's begin. Importing the NumPy module using an import statement. Creating a one-dimensional array, A, using the array method. Simply pass a list of numbers to the array method and a NumPy array will be created. Now let's create a two-dimensional array using the array method. Here we will pass a list of lists to the array function. As you can see, creating arrays in NumPy is so easy. We can access the elements of an array using indexes and the index operator square brackets. Index starts with 0. For a 2D array, a single index returns the corresponding row of the 2D array. For accessing a specific element, we need to pass two indexes, the row and column indexes. This was just an introduction. NumPy is a very powerful module and works very fast. So, it is extensively used for data analysis. Now we will move to our next topics one by one. Various attributes of NumPy array. Let's create a one-dimensional array, A, and a two-dimensional array, B. As we can see, the array, A, has just one dimension and array, B, has two dimensions. In NumPy, dimensions are known as axes, the plural of axis. Thus, a 2D array has two axes. We can get the dimension of an array using the ndim attribute as shown here. The shape of the array is a tuple of integers giving the size of the array along each dimension. The size attribute returns the total number of elements of the array. Mathematically, this is the product of the elements of the array's shape. The dtype attribute returns the data type of the elements of an array. Note that, data types of all the elements of a ND array is the same. Int 32 stands for 32-bit integer and float 64 stands for 64-bit integer. The item size attribute specifies the size of each element of an array in bytes. Various other ways of creating NumPy arrays. We can mention the data types using the dtype argument. Creating an array with all zeros. The shape of the array is passed as an argument. Creating an array with all ones. A 4 by 3 arrays of all zeros. A 2 by 3 arrays of all ones. An empty array with random values. The randomly selected values are based on the current memory status. Slicing of arrays. Like string slicing operations, we can also perform slicing operations on NumPy arrays also. Slicing operation extracts a part of the original array. Here are few examples. Array_1D is a one-dimensional array. This is our original array. Now we will perform few slicing operations on this array. Return an array with the elements with index position 2 to 4 of array_1D. Note that the end index is exclusive. Only these elements are returned by the slicing operation. Now let's perform few more slicing operations. Just follow the comment lines for ease of understanding. Assigning the sliced array to a variable. Now we will learn how to slice 2D arrays in NumPy. Let's create a two-dimensional array, array_2D. We are passing a list of lists to the array method for creating the 2D array. Now let's perform few slicing operations with this 2D array. Please follow the comment line for explanation. Arithmetic operations of NumPy arrays. When we perform arithmetic operations like addition, subtraction, multiplication, division etc. on two or more arrays. We get a NumPy array by applying the operator to the corresponding elements of the array. Here are a few examples. Now let's perform the same arithmetic operations on two two-dimensional arrays of the same shape. We can perform many other operations on NumPy arrays. We will cover more on those in our next lesson. Let me finish here. Thanks for watching. Please like, share, comment and subscribe the channel for more such useful lessons. Thank you. Happy coding, bye.